Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning experience brought to you about MinIO. My name is Cody J. Brown, and I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I do need to cover just a couple of housekeeping notes. Today's session is being recorded. If you miss any of our discussion, or maybe you'd like to share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we'd like you to go ahead and send those in to us using the Q&A tab on the right side of the screen. And for your other comments, we'd like you to use the chat tab. So go ahead and start warming that chat tab up for me by letting us know from where you are joining us today. Now, before we close out, we are going to be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our discussion. The topic of our program today is object storage as primary storage with Veeam V12 and MinIO. I'm joined today by Echo Wilson, engineer at MinIO, and Steve Firmus, senior solutions architect at Veeam. Echo, Steve, thank you both so much for joining me. How would you guys like to take it over from here?
Hi, everybody. Today we're going to be talking about Veeam version 12 and MinIO and using object storage as the primary storage for Veeam backups. In this webinar, we're going to talk a little bit about the object storage revolution. I'm going to cover the rise of object storage. I'm going to let Steve cover version 12 before I start talking about why MinIO is such a good fit with V12 and the fact that it's got this object-centric focus. 3 years ago, Anton Gustav of Veeam made a strategic bet on object storage. He saw then what I think is obvious to everybody now, that object storage is going to become the dominant type of storage in the modern cloud-native stack. And as a result, Veeam began the process of making object storage a first-class citizen in V10. And today, with the launch of V12, that transition is nearly complete. Before I let Steve cover the specific object storage features in V12, probably makes sense for me to cover a little bit about why object storage has become the primary storage in the enterprise. So the first thing is that object storage is scalable. When you compare it, especially to older solutions like NFS or distributed file systems, object storage can be scaled from petabytes to exabytes. And essentially at this point, you could consider it to be infinite storage, right? I can scale out as far as I need to, and there's no practical limits with today's object storage. Object storage is expected to be durable and immutable. So durability means if I lose a drive or a set of drives or a server or set of servers, the data should always be available and the application should be completely unaware of the fact that there's anything going on at all. And when those hardware components are brought back online, the objects should be healed automatically. The missing parts or whatever data needs to be healed should happen automatically with no interaction from you. Immutability means that I should be able to put an object, and based on rules that I've set, that object should not be able to be deleted or modified or mutated in any way. And then it comes with a kind of extra option of versioning, that I should be able to upload the same object again, but keep multiple versions of that object and restore or delete or do whatever I want to a given specific object. It should be accessible, and with the S3 API, you could say that it is, at this point in history, is ubiquitous and pretty much used everywhere. So most applications that are writing for object storage are using the S3 API. There are many avenues to access. So Amazon has their own SDKs. We write SDKs. The Amazon SDKs work with MinIO. MinIO SDKs work with Amazon and with any S3 provider. Anybody that's fully S3 compatible, these APIs and SDKs will work with. And there's also command line utilities like the AWS CLI or the MinIO client, and those will work as well. So having lots of avenues to get to that data. It's flexible, so that means I can store any type of data and I don't have to care what the data is, and applications should be able to access it and do what they want. So if that is Veeam backups or machine learning workloads or anything like that, I should just be able to have access to the data and have it be seamless. Because it's cloud native, object store, or at least software-defined object stores, are cloud native. So you should have the ability to deploy in any kind of orchestrated way that you want, containerized way that you want, and make deployment simple. And finally, it's descriptive. So that means that not only do I have that cloud native declarative operating model, but I also have the ability to tag objects either with Amazon S3 tags, or Amazon S3 API allows for massive amounts of metadata to be attached to files. And so that metadata can be used to do any number of operations, from identifying what kind of data you have to being able to do like transforms on the data or migration of data and things like that. So with that, I think it's time to hand over to Steve.
Hey, thanks, Echo. And thanks, Cody. Echo, it's been great to do another presentation with you. So as Echo alluded to, Veeam, we started using object storage, when 9.5.4 came out. And at that time, we saw object storage as having potential, but at the time, it didn't have the performative values that we needed for in the initial copy or initial target of a backup. We did see that with block storage and file. So object we saw in the, what the vendors were providing was absolutely the best for capacity. Scaled, as Echo mentioned, basically infinitely. But there was that latency issue where it wasn't as performative as it could. So go next, Echo.
Sorry. Am I on the right one for you? Sorry. Good.
Well, that's fine. I think there's another one back, Echo.
Is this the correct one, Steve?
Nope. No, we need to go back to the one that. There we go. All right, next one. Yeah, perfect. Awesome. Thanks, buddy. No problem. So, as I said, so when we released, 9.5.4 back in 2019, that was our first implementation of object storage. And what we did was we had it implemented as what we call a capacity tier. So as that previous slide showed, capacity was absolutely the strong suit of object storage at the time. So that's where we created what we call the capacity tier. So within Veeam, we had the performance tier, which was your initial backup target, which was block and file. And then we had object storage as the capacity. So it basically extended the capacity of the performance tier. And this was done through what we called the move mode. So we would take data. So you could say, let's say, keep my backups on my block and file for 14 days. Anything older than 14, move it to the object storage, the capacity tier. So that did is it allowed you to, if you had 30 days, let's say, of backups or 60 days of backups, pick a number on that performance tier. This gave you quite a bit more room on the performance tier because you moved off, probably 70, 80% of the data to the object storage. And this was great. Then in version 12, basically a year later, version 12, version 10, I mean, in 2020, that's where we took advantage of the immutability feature. So as Echo talked about, the whole, writing the data to a repository and, it can't be touched, right? It can't be deleted, changed, anything, basically it's untouchable until the object lock date is reached. And at the same time, we introduced what we call the copy mode. So this was the ability where you would have your, again, let's say 30 days in the block and file, but then you could make an immediate copy to the object storage. So again, as object storage improved, we saw the use case being able to expand. Then in version 11, again, almost a year later, we introduced some performance throttling because the object storage was getting there performance-wise, but there were still some limitations. So we put in some mechanisms to allow some adjustments in performance. Now, this year, just a little over a week ago, we introduced version 12, and version 12, direct to object storage. So this is where now, you can do almost, everything. There are some use cases, we have a slide later show it, but there are a few things that can't, but the vast majority of what you back up today will be able to go direct to object storage. And also part of that is we have the ability, what we call extents or multiple repositories. So you can have many object storage repositories, within a sober being your initial target, and the ability to offload or copy to the capacity tier as well. So extremely, version 12 is definitely our acknowledgement that, object storage has become as performative as we need, and it's there. Like I said, as Echo said, I won't say the journey's complete, but it's getting close. Next one, Echo. And the reasoning for this was, if you remember the earliest slide where the object storage was not performative, no longer the case. We've worked with MinIO since 9.5.4, and even before then. Over the years, we've worked with them extremely closely to work on performance tunings on both sides. And MinIO is definitely the flagship example of how on-prem object storage is now right up there with block and file on the performance end, but has all the additional benefits that Echo mentioned earlier. The scalability, the security. So are there still use cases for block and file? Sure, but object storage, on-prem object storage is, certainly backed by MinIO, is probably going to be, majority of your workloads could be protected by it. Next one, Echo. And to further prove this, right? The cloud, right? Try to explain to people, hey, mom, your pictures are being sent to the cloud. Where's this cloud thing? It's not really a place, right? It's an operating model. And we did see, as everyone knows, over the last several years, huge push about going to the cloud. And one of the major reasons for that was the benefits of the object storage, right? All those little icons that Echo had on his slide, scalability, performance, security, all that great stuff. What we've seen over the last few years is a trend of folks bringing back workloads from the cloud to on-prem object storage, as well as plans in the future to do so. So on-prem object storage gives you the benefits of the public cloud model, but it also gives you the advantages of security and stuff, and having it on-prem and being in your environment. Next one, Echo. And as I mentioned earlier, within Veeam we have the the sober, right? That's our scale out backup repository, and this is something Veeam has had for many years, and it's always been, again, that scale out architecture, right? And how you did that was in your performance tier. Let's say each of those MinIOs was, let's say a petabyte, and hey, my environment's growing. I need to add another petabyte. Toss in another performance tier repository, and then another one, and keep on going. So, in version 12 with object storage, I show two, but you can have, hundreds, thousands of those performance tier extents, as well as the capacity tier, right? Same thing. And prior to version 12, you could only have one MinIO target. So you would have many performance tier extents, block and file going to a single MinIO. Now you can have, MinIO to MinIO, one to many, many to one, many to many. It all depends on, your performance needs and your capacity requirements and retention policies. But a key thing about this is it's end-to-end immutability. So, you back up to your MinIO on site, in the performance tier, immutable. You're going to send it across the wire, encrypted to wherever, right? Secondary site, colo, again, pick where you're going to store that second location. Again, encrypted end-to-end, going immutability end-to-end, it'll be residing in the capacity tier as well as immutable. all policy-based, completely automated. There's nothing you do. You set, copy to capacity tier, and that's it, and off it goes. So extremely, extremely efficient process. We use a block cloning type algorithm when we send the data across, so we don't send over duplicate objects. Also, MinIO. MinIO has gone through and passed the Veeam Ready program for both object and object with immutability. And for those not aware of Veeam Ready, Veeam Ready is our validation program that goes through and tests, not only functionality but performance. As Echo referred to earlier, obviously our object storage is based on S3 APIs. Part of this test is to validate that MinIO has implemented the APIs that we use, and they've done it in a way that works with Veeam, and that has all been validated. And they, proud to say, they have been a Veeam Ready participant since the launch of our object storage back in 9.5.4. So, congratulations to those folks. Next one, MinIO. Echo. As I said, version 12 launched just a little over a week ago. Again, the direct to object storage, huge, huge, huge feature. I mentioned that end-to-end object storage, where prior to version 12, only the capacity tier was object storage. Now it's the whole, your entire Veeam, storage environment can be object storage now. We did change, some of the way we stored the data to be more efficient. So, as I said, through the iterations of 9.4, 10, 11, and 12, we're constantly improving our object storage technology and engine. And we do that through collaboration with our partners like MinIO. So, with our joint customers, we'll analyze performance, see what's going on. We'll engage, each other's engineering and product management teams and see what we can do to each of our products to, make them better for each other and make them better, more importantly, make them best for the customers. So that's one thing that we came up with. Multiple buckets. I talked about, having multiple performance and capacity tier extents. That was a huge benefit for performance and scalability. Enhanced ransomware protection. So we made some changes in 12 that allowed us to use object storage better to recover from a ransomware attack. So again, extremely, extremely important. In the standalone immutability, right? You can't speak enough about the immutability of using the on-prem object storage at MinIO. It's just tremendous. It's basically what allows us to provide these ransomware protection. Certainly not just ransomware, but even insider attacks. Having that data untouchable is huge. So next one, my friend. As I mentioned earlier, pretty much everything you have in your existing environments can be backed up directly to object. As you'll see, at the bottom, there's only a few use cases where today those aren't being backed up directly to object storage. But again, almost everything else that you can think of. So we'll go by that, the world famous 80-20 rule. But I would say in most cases it's significantly higher than 80. So again, you can go through the list. You can see, again, almost everything that we have out there is protected. Next one there, Echo. I think that was you.
So we'll talk a little bit now about what makes MinIO different. So some of our guiding principles. First of all, we're cloud native. So not only do we just run in Kubernetes, we're sort of born in it, and we've had a containerized, orchestrated mindset from the get-go. On our documentation site, we list 5 different Kubernetes vendors, including AKS, EKS, Upstream, and OpenShift, as well as other undocumented Kubernetes vendors like Rancher. We just sort of expect if it's Kubernetes, we're going to work. We have a Kubernetes operator to make deploying MinIO clusters incredibly simple, just sort of that same declarative model that we talked about before. We're performant, So we put a lot of effort and engineering time into making sure that whatever hardware you give us, we're going to go as fast as that hardware can go. We'll go over our benchmarks a little bit in these slides, but we do publish our benchmarks so that we're not just saying it, we're showing it. And then finally, internally, we believe that simplicity scales. Coming from distributed object storage or distributed file system background, we know that the more complex you make things, the more difficult it is to fix them, the more difficult it is to maintain them and expand them and all of those things. So we do everything as simple as possible, just to make getting up and running easy, and going back to our kind of fast stuff that we're talking about here. So this is a list of the numbers from some of our benchmarking. On the right-hand side, you'll see some hard drive numbers. On the left-hand side, you see some NVMe numbers, but the ones that we are concerned about for this slide are the bottom left, where we're talking about the 32-node NVMe network. If you look at the gets here, the gets are going at 325 gigabytes per second for a 32-node cluster. So that means each node is doing about 10 gigabytes per second. So it's saturating that 100 gigabit network, and you're getting the full hardware speed. These benchmarks are published with that link below, and the benchmarks are meant to be repeatable. So if you'd like to test these in your own environment, the things that you need to do that are in the benchmark itself. So what makes MinIO fast? First of all, we are a single layer. We only do object storage. We do one thing and we do it amazing. We believe that multiple layers are going to cause not just complexity, but the potential for latency and just making things not go as fast as is possible. And we want to be as fast as possible. We have no metadata database, so there's not a place to fail on a lookup. There's not a place that needs to be scaled out, and there's no concern about, if I don't have access to the metadata database, how do I get access to my objects? The way we accomplish that is with a deterministic hashing algorithm, and that algorithm will basically look at the path for an object and the object name, and then say, based on that information, this object will always land here, and I can always get this object back from here. So there's no lookup needed because it's done at the time that the object is persisted based on that hash. Next, we use SIMD acceleration. Excuse me. So that's things like AVX2 and AVX512 for x86 and Neon for ARM. And the long and short of it is that with the acceleration that's provided here, it means that all of your data can be encrypted, and the overhead is so low that there's no reason not to do it. So having data that's fast and encrypted is not something that always happens with other solutions. So this is great that you can have security and performance at the same time. And then last, we use Go, which by itself is pretty fast already. And then we use Go assembly language. So we're doing actually assembly language calls down to the hardware, and that's why you're not seeing overhead in the hardware itself. We're not spiking CPU or using up tons of RAM. We're just saturating those IO subsystems, which is really what you want. So we did recently run a benchmark for Veeam version 12 with MinIO. If we look at the bottom of this slide, we're actually backing up over 100 virtual machines to 8 MinIO nodes, a cluster of 8 nodes, and the throughput we were getting was 12 gigabytes per second. So that means that when I'm doing my backups and restores for just a small cluster like that, I have an RTO and RPO that's just outstanding. So one of the things that MinIO allows is decommissioning and also pool expansion. But here we're just going to talk about decommissioning for a simple example. So we sort of expect that within your data center, you're going to have a bunch of different types of hardware, right? You would have bought a rack of this model of server and half a rack of that model and this and that, and you're going to have a bunch of stuff all over the place. And if it's 2 years since you made the purchase, you're not going to be able to go back and purchase that old hardware. So with that understanding, we have this concept of pools, so you can use many pools to create a single MinIO cluster. But let's say that you've expanded a few pools. Now I have all that storage, but the new tier that I've put in, the new pool that I've put in, has enough capacity and enough performance to where I don't need the old pool anymore. I can repurpose that pool by using this decommissioning. I decommission it, all of the data gets moved over to the new pool or pools, and now I can use that hardware for Minecraft servers or cat videos or whatever I want. So now I'm going to give a quick video demonstration of backing up MinIO or backing up Veeam directly from the object storage. So before we're starting this backup job, we've already created a MinIO tier. And so MinIO is going to be used directly for the object storage here, or is going to be used directly for the backup. So we're going to go through and create our regular backup job. When the bucket for the Veeam tier was created, that bucket was created with object locking, which allows immutability. So having that immutability is one of the key things that we want to demonstrate here. So I just pick a handful of VMs and throw them into the job. As I go through, we see that MinIO is the target, and then we have this retention policy. So I'm just going to set that retention policy here to 1 day, and nothing can be deleted or anything like that unless it's past that expiration date. And of course, you would want to set that longer, but this is just for a demo. So as you go through and start running it, the job will kick off. Veeam in the background is doing some probes to the object storage and saying, are you available? Is the bucket that I need there? Does that bucket have the ability for me to write objects, et cetera, et cetera? And so to verify that, we actually have our MinIO client, which is a command line utility that lets you do administration functions and puts and gets and S3 API calls in a very simple manner back to the object storage. And if we go to the command line and we run this mcadmin trace, then we can see all of the HTTP requests and responses coming into the MinIO server. And so we know that Veeam's doing its job. It's writing objects. It's writing quite a few of them. When I go back and look at the console UI, which is our UI for MinIO, for those that choose to use it, you can do that same functionality where I start running this trace, and then I see that these put objects are happening in quick succession to the MinIO server. So now, after this has been completed, I want to make sure that the objects that I've written are actually immutable. And I alluded to earlier in the slides that part of immutability is the ability to allow versioning. So versions say, I put the object, but the object has a new version and didn't overwrite the existing object. So when I do this delete, I'm going to go through and delete the Veeam bucket. I'm going to also say, I don't just want to delete the bucket. I want to delete every object that was in that bucket and all of their versions. Right? So when I go to do that, I'll immediately see a return. And that return is saying that this object is worm protected, meaning immutability is turned on. I can't delete it. So if I went to the command line and tried to use a little bit more of an aggressive form of saying use force and dangerous, saying kind of kill it with fire, and I run this against that same bucket, it still gives the same message. There's nothing I can do to delete this. And if I look at the JSON response for that error code, it's just telling me, no, you're not allowed to do those things. Okay. So a few pro tips about those, or about that video. One of the things that you can do after you've done some of your basic testing is extend into using policies and user-based or policy-based access. So you can say with a policy that this user or group has access to this bucket or prefix or whatever path that you want within the object storage, and you can say which API calls they can do. So you could say that one group has the ability to download objects from a bucket, and another group only has the ability to see objects that are in a bucket. So the link in this slide will show you all of the possible S3 actions that can be implemented through IAM policies. So Veeam themselves have documented policies that you need for using Veeam. The KB in the upper right-hand side here has two separate policies. One policy will be for regular buckets with no immutability, and the second will be for buckets with immutability. So choose whichever one you're using. The main point is the immutable policy has additional policy actions for things like checking the object locking and things like that. Extending a little bit on what we showed with the MCAdmin trace from the video demo, what we're seeing here is the response to a delete request. So when we tried to do that delete, it actually sent 1,000 deletes at once. Like, let's try and delete 1,000 objects. And here's the response from it. And in the response, you can see that same error message. All of these things that are highlighted with worm, they're all saying the object is worm protected and can't be deleted. So it didn't matter what the object was, where it was, can't be deleted. So in summary, we're living in an object-centric world. So object storage was always the storage class of the cloud, but now it's moved on to the storage class of the enterprise implementing cloud. Performance matters. So our benchmarks show that we're the fastest object store around. We not only publish it, but we offer the ability for people to test on their own so that they know that it's as fast as we say it is. And having that speed, like we're talking about the 12 gigabytes per second in the slides, or in the Veeam benchmark, is saying that I can restore a 100 gigabyte virtual machine in just a few seconds. And that kind of ability to get back up and running after an event, like a ransomware attack, just is incredible. And the last thing is that, as you saw in the video, Veeam and MinIO are both simple to deploy, they're simple to operate, and they're simple to scale. And simplicity is a core tenet of data protection, and both Veeam and MinIO live it.
All right, so let's go ahead and take a look at some of the questions that we've received, and let's see what our thoughts are. So our first question reads, what hardware is recommended to get the most out of Veeam v12 and MinIO?
So from a hardware perspective for MinIO, you want to make sure that the hardware you're bringing is equivalent to the workload you want to do. So if you need to do those 12 gigabytes per second restores, then the hardware needs to reflect that. And if you have more basic needs, then you can use more basic servers with 10 gigabit network, as long as you're getting those RTO and RPO satisfied, right? If I'm getting things restored in the manner that's quick enough for my business objectives, then that's all I need, right? And I'd say that one thing to keep in mind is that object storage as a use case typically grows. So once people see how successful Veeam is, then they're going to want to try Spark jobs or in-house applications or things like that. So speccing for just one application may not be sufficient. You may want to actually spec for lots of applications.
So our next question is, when will MinIO be officially certified for Veeam 12 direct-to-object feature?
Sure, Steve. So first of all, so Veeam doesn't have a certification program, but we do have our Veeam Ready program, which is a validation, and it will be released. Our target is this quarter, and when it does, MinIO will be one of the first to participate.
So will MinIO support the new Veeam 12 agent operations, which are relying on the official AWS IAM and STS API operations?
So the assumption is yes. We've been supporting STS since 2018, probably before then. So STS is kind of built into what we do, and anything that's using the S3 API is going to work with us. So the assumption is yes, but it would have to be tested.
Is a MinIO distributed with 4 nodes and 4 disks, each all HDD, enough to use as a primary repo?
Depending on your uses, right? So that's the minimum that we recommend for production. That gives you sufficient HA guarantees and durability guarantees. And as long as it gives you the performance that you need, then you're fine. So looking at 4 hard drives each per server, you're looking at 800-ish megabytes per second, which is a little bit under what a 10 gig network can do. So maybe you throw a couple more disks in there. But if 800 gigabytes or 800 megabytes per second per server is sufficient for your workload, then yes, more than certainly that's fine.
Is instant restore supported for Veeam from MinIO?
I think that one's for you, Steve.
Yes, oh, absolutely. Yeah, I mean, the instant VM recovery, that's one of the things that Echo is showing as part of the benchmark testing that they did, a little while ago. Absolutely, absolutely supported it, and not only is it supported, it's blazingly fast. So, yeah, it's one of the hallmarks of MinIO, the performance and ability to do truly instant VM recovery.
So from a performance point of view, is it recommended to use a reverse proxy like Nginx in front of MinIO?
So there's a lot of layers to that question, but there's a few things that you can do. Performance-wise, the load balancer would not usually be used for performance specifically, but more for routing and availability. But we do actually have something called Sidekick. So Sidekick is an application load balancer, and you would deploy that on the application servers, in this case, Veeam. Veeam would point to the Sidekick server, and Sidekick would do all the distribution for you. Because it's application load balancer, there's no choke point. It's each server that has it deployed is doing the load balancing on its own, so you have the aggregate performance of all of the clients. So Sidekick for applications would probably be your best bet. But if you have an F5 or Nginx and it has sufficient throughput, then use whatever works. But if you didn't have sufficient throughput on the load balancer itself, then Sidekick is probably a great option for Veeam for you.
Great, thank you so much. Next question, what is the recommendation regarding NIC teaming for MinIO servers?
So there's no recommendation, right? When we talk about doing simplicity, simplicity scales, and if you have to do a bunch of different tuning on things, then really you're not, like, how much performance are you getting if you're spending tons of engineering hours figuring out what you need to do and maintaining it. So for NIC teaming, really all you need to do is make sure that the switch actually is supporting the teaming. So if the switch supports it and you've done the LACP bond, then you should get for 210 gig NICs, let's say you should get your 18-ish gigabits per second or better if you have a better network.
So is there a performance difference in running MinIO as bare metal installation versus containerized?
No. Or if you could find it, it would be so negligible that it couldn't really matter. We have customers running in Kubernetes. We've done plenty of benchmarks in Kubernetes, and those benchmarks are still the same performance as hardware. So,
all right. Thank you. This one is a little bit specific, but is there a file name size limit coming from MinIO? Because using S3 buckets for encrypted things, some file systems rejected them as having too long file names.
Yeah, it's part of the S3 spec, and we follow the S3 spec. So you can't do more than, I believe, 1024 as the total prefix and object path. So it's 1024 characters total, but there are limits on prefix length and object length in addition to the overall 1024 limit. So, but yeah, if you're talking about file names specifically, we follow the S3 spec.
Now, does deploying a MinIO cluster with 8 nodes on Kubernetes with PVCs as backing storage, does it require extra PVC backup?
No, that's the entire point of MinIO and the durability that we talked about in the first slide. So if you have PVs being presented, then whatever amount of PVs that you have, we're distributing. Excuse me. We're distributing the objects across those PVs across all of the worker nodes, and so in a 8-node configuration by default, I believe I should be able to lose 2 servers possibly more. I have a calculator for it, but I don't have it up right now. But you should be able to lose tons of disks and tons of servers and never know that it's running from an application standpoint, and you just need to bring those nodes back online and everything's healed automatically and you don't have to do any work.
Awesome. Sounds good. Is there perhaps a walkthrough for not only setting up MinIO, but the underlying server, i.e. Ubuntu Linux? And also, what are the best practices regarding user creation, the lockdown, firewall, etc.?
That's quite a mouthful. MinIO is a static binary, so it doesn't matter what operating system you deploy it in. We do recommend that you have at least a 4x kernel, and we'd recommend a 5x kernel, especially for performance workloads. We only support the XFS file system. Any other file system will probably work, but we've seen issues with them, specifically ZFS and XT4 come to mind. So I would avoid those and just use XFS. You don't need special tuning options for XFS or mount options, besides wanting to make sure that you have either mounted with label or UUID. And both of those are things you should be doing in any Linux system, whether you're using MinIO or not. So as far as firewall tuning, we only have port 9000 and 9001, and those are configurable. You can change them to something else if you want to, but there's not complex firewall rules that you need. There's no syscontrol tuning that's needed if you're on at least a 4x kernel. And so, yeah, there's not a bunch of stuff that you need to do at the OS level, going back to the fact that we don't want you configuring 10,000 things, because then you have to remember 10,000 things. We just want you to deploy it and be good. And then the deployment itself, we have great tutorials in our documentation, and I recommend that anybody that's interested in MinIO should read through our documentation, because it's succinct, tells you what you need to know, exposes you to the concepts, and tells you how to deploy it. So there's really not tons of documentation, and that's on purpose. So we want you to be able to read through it in a couple hours, and just the initial deploy, reading that document is less than 20 minutes. So
awesome. Yeah, sounds like good resources to have. Would you mind putting in the chat, or maybe Jonathan, somebody put in the chat where those resources could be found? But we'll go ahead and move on to the next question. So is there a practical limit to how much data you can back up with this solution?
No. there's not really a limit, right? So the practical limit, not to sound facetious, but the practical limit is the limits of physics, right? So whatever the limits of physics are, that's what it is. And after physics comes budget. So if you have physics and budget taken care of, there is no limit.
Awesome. Is there an optimal choice for the underlying file system for best performance? If there's no preference, is there anything that you would specifically recommend?
Yeah, so XFS, as mentioned before, is the preferred file system, because all of our benchmarks are run on that. Like, you can see that XFS is able to do the full speed of the hardware, and so we just recommend that. And other file systems that we've used and that our customers have used have not all been as seamless. So I guess one thing that should be noted that's particularly important is that MinIO expects JBODs to be presented, so that you're not giving these extra layers like LVM or having a RAID layer underneath. MinIO is handling the durability and is much faster than RAID in reconstruction. So don't use RAID, don't use LVM, don't use anything else like a distributed file system or NFS or anything else to back it. Just give it raw physical disks, or at least formatted physical disks that are presented as local JBODs, and that's all you need.
Awesome. So this is in reference to MinIO as an object storage server. So what are the key features and benefits that separates it from competitors in the market?
So first of all, we are fully S3 compatible. So they test on us and we test on them. So our SDKs are tested against S3, the actual Amazon S3. In addition to MinIO, they test on our stuff. So compatibility first. The performance, the numbers speak for themselves, and we publish those benchmarks and welcome anybody to challenge them because you can't. So they're pretty rock solid, and we would love people to be testing on their own and giving their own great experiences with it. So yeah, there's not really anything else in that regard, I suppose.
Awesome. Our next question reads, is it easy and recommended to scale up MinIO, for example, from 8 nodes to 16 nodes, or just deploy a new site and move data?
So it's actually very easy, and that was the decommissioning slide. We talked a little bit about the scaling and expansion via pools, pool expansion, but essentially the only thing that I need to maintain is the parity ratio. So when we create, MinIO does everything distributed in erasure sets. So erasure coding is kind of like a way to say how the object is sharded across disks to make sure that it can be mathematically reconstructed. So that parity setting by default for us is 4, but the erasure set might be a different size, like 8 nodes or 8 disks or 16 disks, et cetera, et cetera. So as long as the new pool has that same parity setting, then you can do the expansion, and that's it. There is one consideration that if I have a different erasure set size, like let's say I have a smaller erasure set size of 8 versus 16, 4 parity on 8 disks is different than 4 parity on 16 disks from a storage consumption ratio.
So we have received this question again. What is the file size limit in MinIO?
The same as S3, 5 terabytes. Although we are working on actually extending that. So I don't know what the final determiner is for that. But for terms of this discussion and in this exact point in time, file limit is 5 terabytes per the S3 spec.
Can we have one cluster for Veeam data and other production data? What is the recommendation?
Well, I mean, Veeam data would be production data, right? But you can have as many clusters as you want. You can differentiate in any way that you choose. If you wanted to have tenants, it's easy to do multi-tenancy in Kubernetes, as long as the hardware that you're presenting has enough performance to satisfy all of the workloads that you're presenting. Otherwise, you can do physically disparate clusters and just kind of set stuff off. Veeam backups going to one cluster and other applications going to another. Your choice. And you can do multi-tenancy in bare metal, but at that point, you're sort of having to write the orchestration logic on your own. We stick to Kubernetes because it's already been done, and we don't feel like reinventing the wheel.
Of course. So do you have any tips for optimizing RTO and RPO?
I mean, if the hardware is spec'd, you can't really go faster than the hardware. So MinIO is already optimized completely. So if I would say the only thing that I could think that wouldn't be an optimization would be testing, right? Make sure that my backups are restored in the actual RTO time frame and that they're working. So that gets missed more than it should.
Awesome. Steve, I'm going to have you clarify on a question for me real quick, but as far as I know, MinIO is currently only implementing very few operations of the AWS STS API and no official AWS IAM operations. MinIO comes with a proprietary IAM API. So again, my question is, will MinIO implement the IAM create user operation to support Veeam 12 agent operations?
Sure, and I'm sure Echo can also elaborate. But yeah, so what Veeam does is, yeah, I don't know if everyone knows. I mean, there are hundreds of APIs, for both S3, IAM, STS, and all of those APIs have many parameters. So to make it easier for our partners to implement what Veeam requires, we publish for the partners an S3 compatibility guide, and within that guide it has all of the APIs that we use, as well as the features of those APIs, really, different parameters, keywords of those APIs. So that document is constantly updated, and all the partners have links to it. And I certainly, I've worked with MinIO and Echo to verify that they do support what Veeam needs. The IAM STS compatibility is part of the Veeam ready testing for version 12. So MinIO will certainly participate, and and at the time you'll have a report showing that they do have that the compatibility to the degree that Veeam requires.
So honestly, I don't know what's meant by proprietary IAM. Right? We're implementing from the S3 spec, so I don't maybe understand that particular question, but and I would have to find out about create user. But the STS that's implemented now works for anything that uses STS from AWS that our customers have brought to us or that I've tested. So I'm not sure what things are expected that are not working, but I would encourage that if there are features that are not there, if there are features that are not there, you can open the discussion in GitHub, and we'll be happy to look at it.
All right. So it looks like we have about 9 minutes left. So if you have any more questions, go ahead and get those sent in. We are winding things down. Does MinIO have a level of enterprise-grade features that some other object storage solutions offer, such as data tiering, metadata management, and advanced search capabilities?
So the data tiering is available in MinIO, and you can tier to different clouds as well. So if you want to tier to, say, GCS or Azure, those are available. Metadata, we touched a little bit about in the slides. The metadata you're setting through the S3 API. So you use a XAMZ header for metadata, and that allows you, I believe, 8096 characters, so 8 kilobytes of metadata that you can do per object, although of course that would be a little bit excessive. And then search features, don't know what search capabilities are being asked about, but search would typically be done outside of MinIO, right? So you would have something like the audit logs for MinIO would go to something like Splunk or Elasticsearch, and then you would search there, because if you're searching through the object storage, listing an object storage can be seen as sort of the same as doing a select on a database. If I do a listing across a massive amount of objects in the object store, it's like doing a select star against a production database. And it's just not something that you would do. So you do that search against the external either database or like Elasticsearch type thing, and not within MinIO itself, to avoid performance problems. And the same is essentially going to be true with S3, right? S3, they're taking the hit on their servers, but the expense of the query is still going to be large enough to where you're not going to want to do this massive crawl of the entire namespace.
Sorry, it looks like I was on mute. Our next and final question is there a minimum number of nodes?
So there's no minimum number of nodes to make MinIO work. You could run it on a Raspberry Pi if you wanted to, but for production, what we support for our customers is 4 nodes with 4 disks each. And the reason for that, beyond just performance, is making sure that you have enough durability for the data, and that you have the ability to lose a node or 2 nodes and still have operations running, right? So I can run it on a single node, but if I lose that node, or if I lose too many disks in that node, then there was no durability for the data. And that's not a great position to be in when you're trying to have data still around. So I'm seeing a little bit of a clarification on the proprietary thing. So I would have to, I guess, look at this a little bit more, but I think this create user API is talking about creating users within AWS itself, which of course is not like relevant to MinIO at all. So the admin policies that we have are specifically because you're creating it in MinIO, not in AWS. But I would encourage to open this as a discussion in GitHub, and our engineers can take a look at it and see about bringing that in.
Well, Steve and Echo, I do want to give each of you a chance to leave our audience with any final words or anything that you feel they need to know before we close out. So, Steve, you want to go ahead and get that kicked off?
Absolutely. Thanks, Cody. Yeah, I mean, all I can say is, certainly, version 12 with its, I want to say its focus on object storage, but certainly with the introduction of the direct to object storage, one of our primary concerns, has always been performance, and will object storage, perform similar to block and file, if not better, and partners like MinIO, have made that happen. So MinIO, like I said, they did that benchmark testing not too long ago, blazing. As someone asked earlier about practical limitations or anything like that, we could not throw enough data at MinIO to cause it to slow down. The bottleneck was always the network or even the source. We couldn't do anything to flood or crush MinIO. So if anyone is looking for object storage and looking for it as the primary backup target, you have to look at MinIO. It's they are blazing fast.
Yeah. I'll do one quick final clarification. So saying that the Veeam 12 agent operations rely on that policy or on that IAM action. If it's required for Veeam 12, then I have to assume that it would be implemented either directly or in a way that makes it seamless. So it's not something I would be concerned about in particular, but you can open a feature request. But if it's required for Veeam, either it already works via whatever functionality, or we're going to implement it. But I would not expect that we would not have that working. So going to the MinIO side of things and last thoughts for the audience, MinIO is built to be simple, like we said. And as I alluded to, you can run it on a Raspberry Pi. So anybody that wants to test MinIO with Veeam, getting that test up and running is actually quite simple. You can just deploy MinIO on the single node for testing. You can do all your functional testing. Of course, that would not be suitable for doing any kind of performance testing. But if you're just looking to see that it works and how it works, I encourage you to tinker around and try and break stuff and play with it. You can also hit us up in our Slack channel at slack.min.io. and ask any Veeam related questions that you have there, or ping us on our website. There's a little chat button, and you can chat with some of us about your questions for Veeam 12 and MinIO.
All right, Echo, I do have one more question for you. Is there a Prometheus exporter for MinIO?
So yes and no. We being cloud native, like we do Prometheus by default, so you don't need an exporter because we're already doing it. You just need a scrape job to scrape the MinIO endpoint.
Awesome. Well, I really appreciate all the questions that our audience provided for us. And Echo and Steve, I really, really appreciate you thoroughly answering every single one of them. It's quite impressive, actually. So to Echo and Steve, thank you both so much for joining me. I'd like to remind our audience that our session today was recorded. So should you want to rewatch this session, you will be receiving an email with a link to access the recording on demand. Or of course, you can find it living on the DevOps website at devops.com/webinars. The 4 winners of our $25 Amazon gift card drawing today are Bhagyalakshmi S, Marcel W, Kim D, and Intando Y. So to our 4 winners, keep an eye on your inbox to claim your gift card. It should arrive in about the next 48 hours. If you do not happen to see it, check your spam folder in case it gets filtered out. I'd like to thank MinIO for sponsoring our program today. And to everyone who's joined us, thank you so much for being here. We really value your time and your participation, and we'd like to hear your feedback and your thoughts on how today's program went. So let us know your thoughts, what you'd like to see on an upcoming program, or if you would like MinIO to reach out to you one-on-one for a demo, we do have that available in the survey, so feel free to let us know. Otherwise, we hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day, and Echo, Steve, thank you so much.